Hello everybody and welcome back. So let's see how we can create these paths efficiently and get a nice result. Now, the first thing I want to do is, instead of using this entire geometry, I went back and played through a couple of frames, and that gave me, if I look at this for example, when I went to the frame where everything is collapsed, I can see there's big gaps in the geometry, and I simply use the part in the center. So things where I see big gaps, I know that the crack is not going to propagate through that, and I focus the energy to only happen in the center. So I'm going to copy this group and I'll show what I mean in a second. So let's copy this as well. Okay, so this is my geometry, and then I put down an assemble node and I selected by hand these groups. Okay, so I know, for example, it's gonna split there, and this piece will stay on the ground and this piece will go up. And I can put down a transform. I'm gonna copy the transform node from this and I'll show what I meant. So this is my geometry deforming, and let's go to frame. Let's go to this frame, for example. So what I meant by the selection is I used only points here. So the crack is gonna continue. It's gonna continue all the way through here. And I did this selection by hand. So I grabbed all these pieces and I followed this. If you wanna consider doing something procedural, you're more than welcome to do that. And for example, this is a big gap, so I will stop. I will only consider these parts, but maybe not this part. This one, it can flow through. So that's how we get the illusion of that the crack is actually stopping here and causing that explosion to happen. But it's only timing. It's not true. Like because of the end point, the crack stops here, and same timing, approximately same timing is when this energy will go up. So then I made this group knowing that, and maybe we can see it here instead. So this is the deformed result, and if we see, let's put the assemble here. Yeah, so that's the separation that I used, and I included some of these because I want the energy to continue in some cases, but pretty much that's the focus region I wanted to use. Cool, so let's go back. We don't need this at the moment. I just need the geometry flat, and we will answer questions we will answer and provide solution to the various problems that we talked about as we progress through this. So this node is called, that we're going to use, is called find shortest path, and I'm going to create a grid. And I want to illustrate how this works briefly, and I'm going to scatter some points on this grid like that. I'm going to use a 2D triangulate, or triangulate 2D, and this is going to give me a mesh from a set of points. And what I wanted from this really is the triangulated set of points. And let's put down a find shortest path. Find shortest path, and it expects a start point and an end point. So let's create a group, call this start, and I'm going to select something like this, and then I'm going to select create an end group. The name doesn't really matter. I'm going to say this is my end group. Okay, so if we set these end and start, we get this nice pattern. Easy. Well, let's put down the color node and colorize the primitives random. And you see that we have the overlaps like we did before, and there is nothing much that we could do about this. The other thing that we could lose is the name attribute. So the data is not gonna be inherited when we use this node. It can be messy. So we need a way to fix that, but we will take a look at it later. Okay, so we need something similar. And if we look at our geometry currently, this is not ideal at all. So we need to clean it up and isolate only the portion that we can use for this node to work. And by that, we're going to delete the inside faces. We don't need them. And let's unpack this. So we're going to delete the inside. Okay. And I'm going to delete anything that is not, pretty much everything that is at the bottom of this. And let me check how I did that. Yeah, so I used the height. So I'm going to use the height position and delete everything. Keep just this layer. Now, let's try this. Let's copy this and select some points at the center. That's too much. Just few points like this, and then some points for the end. And this could be something like this. And then do a find shortest path. Nothing happens. The reason for that is because this geometry is not connected together. There's nothing. But if we do in a single primitive, in a single piece, start here and end here, it's possible that it could find a path. But with this current structure, it won't. The other thing is, I don't want this path to cross a piece. I only want it to be able to travel along the cracks. So we need a way to tell it, hey, you are not allowed to go here. You can only go here. So what we need is we need to create a silhouette of these points, of each piece. So for each named primitive, we're going to loop over. And this is one piece. We're going to use a carve node. Sorry, not a carve node, a divide node. I'm going to say remove shared edges and remove convex polygons. And that's going to give me an n-gon, which is fine because I can work with that. And now if we loop over all the pieces, we get a nice silhouette of all of them. Now still, it's not connected, so we need to use a fuse node and make sure everything's connected. Now, in few instances like this, it's not ideal, so I'm gonna increase the connectivity and just make sure everything blends together in a nice way. Something like this. Okay, so let's put down the groups here and select a couple of points in the center and a couple of points in the end. And let's see how this is going to work now. Awesome. So we're starting to get something. But as you can see here, we have a lot of endpoints and I don't want that. Okay, and I'm not getting nice cracks. So we need a way to be able to artistically control, not artistically, be able to decide how it's gonna look or the number of endpoints and stuff like that. So we're gonna do that in the next video. Thank you guys for watching and see you in a bit.